9, we are finishing up chapter 4 and looking still at SOHCAHTOA. So we're still thinking of sine as opposite over hypotenuse, cosine as adjacent over hypotenuse, and tangent as opposite divided by adjacent. But today's focus is going to be to use sine, cosine, and tangent to find unknown angles instead of unknown side lengths. So if you look at the example that I have for you, we have a right triangle. So again, we can only use sine, cosine, tangent when you have this right triangle. So I'm given a right triangle, but instead of being given an angle, I am given an unknown angle. So I have theta in the corner of this triangle, and I don't know what the angle is. All I know is that I have two sides. The hypotenuse is 7, and the opposite side is 3. So my very first step, let's take a look at our steps. Locate the angle that we're talking about. So here's my angle. It is, in red, my theta. Second step is label the sides as hypotenuse, opposite, and adjacent. We've been going through the same steps when we did the side lengths. So here's my opposite side to theta, and my hypotenuse, which is always across from the 90 degrees. Step 3 is identify the trig ratio that we need to use. So because I'm standing where the theta is, and the 3 is opposite, and 7 is hypotenuse, I am using sine as opposite divided by hypotenuse. So I'll go ahead and now write out my equation. So I know that sine of the angle theta is equal to opposite divided by hypotenuse. And let's go ahead and substitute in everything that I know about this equation so far. So I do not know what sine theta is because I don't have a theta. I don't have an angle to put in. My opposite side is 3, and my hypotenuse is 7. Okay? So here is the new part of today. So I'm going to put a big star on this part. This is new. When you do not know your theta, we use the button on your calculator that says sine with the -1 on it. So in order for me to get rid of sine and just have my theta by itself, I must use the inverse of sine, which is sine with the -1. And then I put in everything that I had on this side, so the 3 divided by 7. I'll substitute that into my equation. So what I just did was I got rid of sine by using inverse sine, so sine with the -1. So if you take the inverse sine, it cancels out the sine. So I just have my theta, which is equal to sine to the -1 of 3 over 7. So using my calculator, if I substitute in sine with the -1 and put in brackets 3 divided by 7, I should get approximately 28.2. And this should be degrees, all right? Take a look at your calculator and make sure that there is a D at the top of your calculator for degrees. Otherwise, it will give you a very, very small number called a radian, and we do not want to use those when we're finding degrees. So let's try one more example together. Second scenario, again, find the unknown angle of the right triangle. We now know how to find unknown sides, so now we're going to find an unknown angle. Now for this triangle, I'm going to give you guys, let's use 15 as the hypotenuse, and let's use 6 as this side length. So my unknown theta is going to be up in this top corner, so I'm going to move it around. So let's take a look back through our steps. Locate the angle. All right, so the angle I'm using is this top corner. Check that off. Label the sides. So I know that 15 is my hypotenuse. I can go ahead and put that down. 6 is now right next to the theta. It's actually one of the sides that makes the theta. So this is called our adjacent side. And I don't have anything else. Identify the trig ratio. So adjacent and hypotenuse. Let me look back for a moment. Adjacent and hypotenuse, I'm going to use cosine So cosine theta equals adjacent divided by hypotenuse. So I've identified the trig function and I've written my equation. So now let's go ahead and substitute in what we have. I do not know my theta, so I'm going to leave the theta empty. My adjacent side is 6. My hypotenuse is 15. Now, here is our new material. Our new material is, in order for me to get theta all by itself, I must use the cosine with the -1 in order to get rid of that cosine. So if I use cosine to the -1, it'll isolate just the theta, will be by itself. But I do have to put in brackets 6 divided by 15, because that's what I had on the right-hand side. All right, so go ahead and use your calculator and find out what cosine inverse, with the -1, is of 6 divided by 15. And we should be getting 73.8 degrees for this one. So what we just figured out was that this angle right here in our triangle is 73.8 degrees, so almost 74 degrees, okay? So if I know that this corner is 74 and I know that this is a 90-degree angle, then I could also find the other corner because I know that my total is 180. So I do have some options now for some other word problems that we might see in the next few days. All right, guys, have a great night. I'll see you soon.